Hello everyone, this is S.Poojitha Nanda studying B.Tech Civil Engineering from GRIET College, and I wanted to talk about the major project which I have done on hydrological modeling using SWAT on Ecosat watershed. My teammates are A.Pravalika and Jagadeesh. Before getting into the contents of my major project, I wanted to talk about watershed. Watershed is a basin-like landform which includes a catchment area and also various land areas with different types of soils which are used for cultivation purposes and various other purposes. But putting in mind the growing needs of the people and the deplenishing of the natural resources, it is very essential for us to improvise and qualitize our watershed. So one of that method to improvise our existing watershed is SWAT modeling. SWAT is soil and water assessment tool. With the help of this SWAT, we can predict the future parameters and future conditions of the given watershed and try to improvise that watershed. How this SWAT works? There are certain inputs we have to give to the SWAT. Let me show you the parameters required for the SWAT modeling. The required parameters are clay content, silt content, sand content, rock fragment content, AWC of soil water, that is available water content, and bulk density, maximum rooting depth, like various hydrological parameters of that land area which we have taken. We have to obtain these parameters and give these parameters to the SWAT. Once we run the SWAT, we get the future predictions of that land area, and basing on that, we can quantify our land management practices. And to find these parameters, we have to do certain experiments. We have done hydrometer analysis and tensiometer, pressure meter test, and total station survey, and co-cutter method, and double ring infiltrometer method. With these experiments, we got those parameters and we incorporated those parameters in the SWAT modeling and run the analysis. From here, my friend Jagadeesh will get on.
The main steps of SWAT are watershed delineation, HRO definition, weather data definition, edit SWAT input, run SWAT. First of all, we have to install QGIS. In the toolbar, you can see SWAT icon. We'll creating a new project. After that, you have to save the project. You can see interface of SWAT. In this new project, we already created a new project. In first step, we have to select delineation watershed, and the second step is creating HRS. In the third step is edit inputs and run SWAT. The first step is delineation watershed. In delineated watershed, we have to select the DEM file, which we already available in the net, which we required in our project. We have selected the DEM file. In the DEM file is hdr.adf in file. Just open it. After the selection of DEM, we need to create the stream networks. The entire DEM is divided into number of cells. For the feasible calculation, we can see the number of cells 90 here. It shows, you can see the blue lines. It shows the stream networks. The stream networks are displayed. In this, inlets and outlets are added here. You can see the deltas over here. The blue colors are these are the deltas. These are the inlets and outlets are added. The next one is we have to select the subbasins that have an area less than 25% of the main subbasins are merged into the downstream subbasins. The point sources are added to each subbasin. Then we have completed delineation watershed. In this, watershed delineation is completed and create HRS is enabled.
After the watershed delineation, the HRUs has to be created. The HRUs are nothing but the hydrological response units. If the subbasins have the same land use and the crop patterns, they are termed as the hydrological response units. In this hydrological response units, we will be giving the land use table as well as the soil table. In soil attribute table, whatever the values we have acquired from the experiments, such as hydrometer analysis, pressure meter test, total station survey, etc., have to be entered over here, such as available water capacity, crack volume, clay content, silt content, etc. And also the next comes the climatic data. In this climatic data, we will be giving the temperature, maximum temperature, minimum temperature, longitude values and latitude values. Later, the important weather data, as I have told you before only, we will be editing the values that we have acquired, and later the SWAT has to be run. These are the animation representation of the result values, and these are the graphs for various parameters such as the date, evapotranspiration, and also the date versus precipitation.
Thank
Thank
you.
you.